Hey everyone, welcome to today's Explainer. We are tackling one of the absolute most critical bottlenecks in modern industry right now. How in the world do we handle the sheer, unyielding volume of data generated by the industrial Internet of Things? If you're dealing with modern factory networks, you know exactly what I mean. Managing operational technology, or OT data, well, it's no longer just an IT headache. It is literally the foundational challenge of the modern industrial age. Okay, let's dive into this and explore the high-tech architecture required to capture, process, and ultimately store modern industrial data at a truly massive global scale. So here's our structural roadmap for today. We are tracking the chronological journey of your data, starting with surviving the data tsunami, moving right through ingestion via Cloud Pub Sub, heading into real-time stream processing, and wrapping it all up with the global telemetry architecture.
Section 1. Surviving the data tsunami.
I want you to picture a massive, global factory network for a second. We're talking thousands of sensors hooked up to robotic arms and pressure valves, all just pumping out chaotic data 24/7. We're looking at hundreds of thousands of events per second. To put that into perspective, it's basically like standing in a packed mega stadium where every single person in the seats is shouting a totally different number at you simultaneously every single second. This isn't just a tiny trickle of data that you can batch process overnight, right? It is a relentless, high-frequency data tsunami.
And this brilliantly illustrates the core conflict we're facing. When your standard industrial servers get hit by this kind of high-frequency data, they completely crumble. You end up with system overloads and, most critically, dropped packets. But the modern plant output is this relentless tsunami that absolutely demands elastic scalability. The old, rigid hardware setups, they simply cannot keep up anymore. Which brings us to our absolute non-negotiable core mission. If we actually want to use things like analytics and AI to optimize our factories, we must ingest this entire data tsunami without dropping a single packet. It's that simple. Because if you drop packets, well, your analytics are immediately flawed. Your AI models end up getting trained on incomplete data. And worst, your real-time alerts might totally miss a critical machine failure. The ingestion phase absolutely has to be flawless.
Section 2. Ingestion via Cloud Pub Sub.
Okay, so the solution here begins with Cloud Pub Sub, which basically acts as our globally distributed data buffer. In this setup, your edge gateway devices out there on the noisy factory floor securely connect via MQTT, which, is a really lightweight messaging protocol that's just perfect for the Internet of Things. They take that chaotic wave of raw data and funnel it straight into an infinitely scalable Cloud Pub subchannel. Now, the real genius here is decoupling. By completely separating the OT devices from the processing engine, you ensure that even if the back-end systems slow down for a second to process complex tasks, the factory floor sensors can just keep firing data into the buffer. Nothing backs up, and nothing crashes.
Think about what this buffer is actually accomplishing for us. Say a machine faults and suddenly blasts out a massive wave of diagnostic data. PubSub absorbs that sudden telemetry spike completely effortlessly. It does all of this with sub-second latency and absolute reliability, again, ensuring we don't drop a single packet. And it smoothly funnels all that edge data via MQTT right into your controlled, secure cloud environment.
Now, what's really interesting about this is the sheer capacity. During worst-case scenario factory floor spikes, this system doesn't just absorb a few extra data points here and there. No, it handles millions of concurrent messages, stabilizing the entire flow like it's absolutely nothing.
Section 3. Real-time stream processing.
All right, now that we've safely buffered all that raw, noisy chatter, we enter the active processing engine, Cloud Dataflow, which is built on Apache Beam. Because our ingestion buffer is constantly holding fluctuating amounts of data, Dataflow provides us with a serverless, horizontally scaling pipeline to match it perfectly. If your data volume suddenly doubles, Dataflow just dynamically spins up more workers and then scales right back down the second the spike passes. There are literally no fixed servers required.
Let's move on and see how this builds together into a cohesive pipeline. Dataflow takes this raw chaos and transforms it through an inline ETL process. First, it strips away the sensor noise and bad reads. Then, it standardizes all those diverse OT protocols into one single language. From there, it transforms the data into the enterprise standard ISA 95 format. And finally, it normalizes timestamps, so an event happening in Tokyo aligns perfectly with an event in Berlin. The final output is a beautiful, clean, fully structured stream of data.
Section 4. Global Telemetry Architecture.
Let's track the lightning-fast journey of just a single data point through this completed end-to-end architecture. At exactly 1 millisecond, edge gateways on the factory floor capture the sensor data via MQTT. By 100 milliseconds, that data has hit the cloud and is securely ingested and buffered in a regional pub subtopic. At 500 milliseconds, our global data flow pipelines have already grabbed that data, cleaned it, standardized it, and transformed it. And at just 800 milliseconds, that perfectly standardized time series data streams directly into enterprise storage like BigQuery and Bigtable. In 800 milliseconds, literally faster than the blink of a human eye, raw sensor noise becomes highly structured data that powers your AI.
By combining the infinite buffering capacity of PubSub with the dynamic real-time processing of Dataflow, we have created something pretty incredible here. We've built a truly future-proof elastic telemetry backbone. Honestly, it doesn't even matter if your company builds one new factory tomorrow or 50. This architecture scales to ingest not just hundreds of thousands, but literally trillions of events without breaking a sweat, feeding an infinite, clean flow of structured intelligence right into your business.
So the crucial point is this: surviving the modern data tsunami isn't about just throwing money at bigger traditional servers. It's about architecting a smart, decoupled, elastic pipeline. You now know the exact blueprint to handle massive-scale industrial data. The only question left to ask yourself is, how will you implement this architecture to transform your own raw industrial noise into standardized, actionable intelligence? Thank you so much for joining me in this explainer today, and I really hope this architectural deep dive has empowered you to rethink your own data strategies. See you next time.